I'll wait till the 3:30 mark. I hope everyone's having a great day. We're going to start right at 3:30. The recording is going. If you've just joined us and you know how to rename your computer, the name of your library, that would be great. We will. Hello, Reachwood. Hello, Woodhaven. Feel free to type questions you have, burning questions in the chat. When we get to the Q&A portion, we will. Oh, Grace, someone accidentally went to the team link. I pulled it off of the invite.
I will send the Zoom link into the team chat.
You know, Teams does that. Okay. Welcome, everyone. Welcome to the Queens Public Library Solar Eclipse presentation with NASA's Carolyn Eng. I am Rita Carl, Director of Programming at the Queens Public Library, and I am your host. And I am joined by Grace Mann, our Program Assistant for Children, Youth, and Families, who will be minding the chat. And after Carolyn's presentations, we'll turn all your cameras on so that she can see all of you and your groups. This is my opening for the Queens Public Library. This is Women's History Month, and Queens Public Library is celebrating change makers, women who have been professional leaders and advocates, like our guest today, for a more equitable world. Learn about our special programs and book recommendations and how you can make your own Queens of Queens vision board and much more at queenslib.org/WHM 2020. Filing taxes can be overwhelming, probably for most of your parents. It's a complicated process, but it doesn't have to be. Queens Public Library is partnering with organizations to offer free tax counseling for New Yorkers at several of our branches. Download our tax help brochure at queenslib.org/tax help. And finally, we have created a new QPL Teens Instagram page. Help us celebrate the amazing teens in our Queens Public Library communities while you learn more about everything we do for teens. Check it out and follow us at instagram.com/QPL Teens. And now, today, our guest is Carolyn Eng, an education specialist in the heliophysics science. It's a great word for today, heliophysics. As a team member of the NASA Heliophysics Education Activation Team, or NASA HEAT, because NASA loves acronyms, she works with researchers at the Goddard Space Flight Center in Maryland and in the office here in New York City and across the country to help develop educational resources for learners of all ages. Carolyn supports NASA in its solar eclipse efforts and has been responsible for many outreach activities and intern programs. Previously, she was an acquisition scientist for the National Space Science Data Center. Since 2000, she has co-led the Sun-Earth Day programming that brings space science content to educators, museums, parks, and the public. She has partnered with the City University of New York on internships and training in the use of heliophysics data. She has managed a high school work-study program and provided underserved students with authentic research opportunities. She is the principal investigator for the Space Weather Living History Project. Welcome, Carolyn. The floor is yours.
Thank you so much, Rita. Can you see my screen? Okay. Hello, everyone. Greetings from Greenbelt, Maryland, which is half an hour drive from the U.S. capital, Washington, D.C. I'm Carolyn Eng, as Ms. Kyle introduced. I'm physically in Greenbelt, Maryland at the NASA's Goddard Space Flight Center, working with heliophysics scientists and educators. So today I have the pleasure to share with you some solar eclipse basics and why and how NASA is involved. So here is a video, a speed up video, what do you think you see? What is it? It is the sun, and the sun is a star. Why would we see it during the daytime? Because it's so close to us. It looks different from other stars that are only visible at night. And how big is the sun? It's really big because more than 100 Earths will fit across the disk, and more than 1 million Earths could fit inside a sun. And how far is it? It's quite far away, 93 million miles. And what is it made of? It's actually made of all gas, and the gas is so hot, it's actually plasma, the fourth state of matter that is electrically charged. And lightning is a kind of plasma. So that's our sun. Now transitioning to the moon. What do you know about the moon? The moon actually is a chunk of rock that scientists think had broken off from Earth. This is an image, also a sped up video. And how big is our moon? It is smaller than Earth, but it's still pretty big, at least bigger than Pluto, our dwarf planet, furthest from the edge of the solar system. And the moon is quite far away, but close to Earth. It is 30 Earths away, but so close to Earth is our only satellite, our only natural satellite orbiting around us. And it's made of similar materials, similar to Earth, mostly rocks, silicon, and there is oxygen and other elements. Because scientists think the moon is really just a piece of Earth, lunar rocks are not that different from the rocks on Earth. And I think Ms. Kao had worked in Johnson Space Center before that actually hosts moon rocks that will return from the Apollo era. And there will be more rocks coming back from the moon when Artemis will land. Okay, moving along. Now you heard about the sun and Earth. Why would the sun so big and the moon so tiny look about the same size in the sky? Turns out it's a math ratio. The sun is 400 times bigger than the moon, but the moon is 400 times closer to Earth than the sun. And so at some point, when the moon moves in front of the sun, it blocks our view from the sun, creating a perfect match, eclipsing the sun. What do you think this image is about? There's a dark circle, a disk, a black disk, and with some lights coming off it, right? This is really an image of a total eclipse taken in 2017. A total eclipse occurs when the sun, Earth, moon perfectly lined up. And the moon is between Earth and the sun, and the moon blocks the entire sun. It's quite special. It only occurs once every year and a half. So every 3 years, you'll see 2 solar eclipses, 2 total eclipses. But because the Earth is covered mostly by water, remember 70% of Earth's surface is covered by water. So if you want to see a total eclipse, like myself, I have to travel out of the country to Turkey and China. And in 2017, USA was treated to a total eclipse. And very soon, in less than a month, it will happen again in the United States. So when a total eclipse happens, people in a specific area in its path will experience a darker sky, much like sunrise or sunset. Not completely dark, but dark enough, like sunrise, dawn or dusk. And during those brief moments, the sun is really beautiful. Its atmosphere, called the corona, can be seen, like rays coming out, right? Because normally we cannot see the sun's corona. The sun's surface is very bright, and so the moon, normally we cannot look directly at the sun. But the moon will block out that bright light during a total solar eclipse so that we can see the corona. Not only the corona and the solar wind that is coming out of it, but also some bright stars in the sky in the middle of the day. Can you imagine that? So here is the moon in the blue circle, and the sun is hiding behind it. And now you see the atmosphere. So, and stars appear. All right, how that happen? A solar eclipse happens when the moon passes between the sun and earth, casting a shadow, right? Notice that it's a very small area, about 100 miles by 100 miles. Remember, the moon is small compared to the sun, so it doesn't cast a big shadow. If observers are in the little dark circle to the left, almost at the equator, it is called the umbra, and that's where you will experience a total solar eclipse. But if observers are in the larger area, the dimmer shadow, which is called the penumbra, they will experience a partial solar eclipse. Everybody in the United States will actually see a partial eclipse next month. This is a small experiment using a flashlight and a tennis ball, casting a shadow, and you will see the big and small shadow. The small one is more focused, and that's mimicking the area of the total solar eclipse. All right. Well, if the sun and the moon always lines up during new moon, then we will have a solar eclipse every month, but it's not quite that way. The math is a little strange. Just a few months ago, something's also happened, but the sun was not completely covered, leaving a ring of light. Why did that happen? Because the moon does not always have the same distance from Earth. It is orbiting in an elliptical shape, not eclipse, but elliptical. So one side seems to be longer and the another side shorter. So when this moon is closer to Earth, we hear about supermoon. But when the moon is further away, the moon looks a little smaller, meaning it's away from Earth. And so it does not completely cover the sun, even if it passes in front of the sun. There's a video here showing the elliptical orbit. Can you all see? So here's the supermoon on the left and the little moon on the right-hand side. You can replay the video, hopefully. That is produced by Jet Propulsion Lab.
Cool.
Perigee means closer, and apogee, like apple, is further, further away. Fancy words, but it has something to do with the orbit. Besides the elliptical orbit, something else is strange. Imagine a piece of paper level on the table. The moon's orbit is not going on the tabletop, but tilted at 5 degrees. Aha. So the moon's orbit is a little above sometimes and a little below. So here's another animation. So notice the red line mimicking the tabletop. The moon is 5 degrees above and sometimes 5 degrees below. So it will not be able to block the entire sun or at all. So the eclipse has to happen just at the right moment. So there are 3 kinds of eclipses, actually only 2 solar kind. One is the total eclipse we talked briefly about, when the sun is completely blocked, 100% blocked by the moon. And then there are the partial eclipses, which happen more often. And then the annular eclipse is a special kind of partial eclipse, which happened last October over the United States. Did anyone see it last October? Maybe in New York? I hope you saw a partial eclipse, right? Maybe not the entire ring around the sun. That was spectacular. Our team traveled to New Mexico during the balloon fiesta, and we were able to see balloon launches at night and also lit up during sunset. So it was magical. And then during broad daylight, the sun was partially covered, but almost centered blocked by the moon and leaving a ring of fire. So if you like the partial eclipse in October, you will be even more excited for this April the 8th, because there will be another eclipse coming. Here is a map of United States. Actually, the eclipse will start from Mexico through the state of Texas and up to the northeast, passing through Arkansas, Illinois, Indiana, and New York. A lot of cities in New York, the state of New York. And then to Buffalo, Niagara Falls, and then Maine into Canada. This map will show where observers will experience the dark in the daytime. The 100% block is represented by that narrow path in dark color. And then outside of the dark path, everyone will see varying size, small bites taken out of the sun. So for those in New York City, Miss Rita, do you know how many percent?
89%.
Close to 90, right? 80 some
Close to
90%.
90. Yeah.
Yeah, it's a big bite taken out of the sun. Okay, so how would you observe the eclipse? I hope people got their glasses or will be getting some eclipse viewing glasses. They are actually solar viewing glasses, but not regular sunglasses. Please do not use regular glasses. Thank you for showing up here. The solar viewing glasses have met the international standard 12312-2. So please check every pair. And before you use, definitely check that they have no damages, no tearing from the lenses, or any scratches. If there are, please discard them, destroy them and discard them. Okay, so these are your solar viewing safe equipment. Without using them, without the proper eyewear, it can permanently damage your eyes. It can burn your retina without your knowing. So again, no sunglasses. But if you don't have glasses, no problem. You can use other methods. It's called indirect viewing, right? On the left is a video.
Hi, my name is Parker, and I'm going to teach you how to make the boxed pinhole projector. To get started, you'll need a cardboard box, cereal boxes, or shoe boxes work great. You also need scissors, aluminum foil, a pencil, a push pin, some tape, and a white piece of paper big enough to cover one end of the box. Start by tracing one end of the box on the white sheet of paper. Then cut out your shape and place it inside of the box on the same end you just traced. Next, cut 2 square holes on the opposite end of the box, one on the left and one on the right. If you're using a cereal box, tape up the middle to help everything stay together. Now cover one of the square holes completely with aluminum foil. Use tape to help the foil stay in place. Finally, take the Bushman and punch a very small hole in the center of the aluminum foil. Ta-da! Always remember, you should never look directly at the sun because it's very dangerous and will hurt your eyes. To use your boxed pinhole projector, stand with your back to the sun. Then hold the large square hole up to your eye and move the box around until you see the sun projected on the paper. Watching a solar eclipse is a great way for anyone to do science. But remember, you have to be careful. Hi, my name is Parker, and I'm going to teach.
That's so great. I did that when I was a kid. We made pinhole camera. I remember there must have been an eclipse when I was very little.
Yeah. So almost every household can find a cereal box or cookie box. So it's a great way to build it together as a family and try it out. And during a partial eclipse, it takes a long time, right? 60 to 90 minutes for the entire process to happen. So you can only wear the paper glasses for so long, and it would be fun to play with a box pinhole projector or a colander or a spaghetti strainer with multiple holes, letting
You know,
the
I've also
sunlight
done
shine.
it, Carolyn. I've used a compact where you cut the
Ah,
mirror except for a little hole,
uh-huh.
and then you reflect it, and you can reflect it on a wall.
Oh, yes, and
That's
project
kind of
the
yeah.
image.
Yeah.
So many people can see it all together. Yeah, great, fun experiments to play with. Okay, so back to the sequence of the eclipse, right? So a bite will be taken out of the sun, and then more bites, larger ones, until the sun is completely covered by the moon. If you happen to be on that narrow path of totality, only those on the path can take off their glasses or filters and look at the corona, the atmosphere of the sun safely, only for those brief moments. And for you in New York City, if you're not traveling to the path, make sure you have the glasses on at all times. Okay. And children, make sure an adult is with you so you can stay safe while watching the eclipse. So why do NASA scientists study the sun, get interested in the eclipse? Eclipse is a great opportunity for us to study our very own star, our closest star, the sun. Helio is a fancy word for the sun, and physics is studying how things work. So during the eclipse, it helps us to understand more the sun's behavior and its impact on our atmosphere, the Earth's atmosphere, as well as the entire solar system. So on the left of the image, you see a quiet sun with very little activities except some rays, some solar wind coming out from the limb. But on the right, you see a very active sun with multiple regions that have activities on it, right? Turns out the sun has seasons, much like Earth has 4 seasons. The sun also has somewhat like 4 seasons, a very calm one, like a summer day, balmy day, and a very stormy sun. But the season takes 11 years to go through one cycle. And a stormy sun can cause problems on Earth by disrupting our technology and also endangering our astronauts in space. And so the study of the sun, its cycles, and how it causes weather in space is called heliophysics. So during the every day, not just during the eclipse, you can observe the sun with your solar viewing glasses or go online and look at the Solar Dynamics Observatory. This is the page, sdo.gsfc.nasa.gov /data. And it shows multiple phases of the sun. And because there are multiple telescopes on one spacecraft, scientists has to use different colors to tell the different layers of the sun, different temperatures. And they show different features of the same sun. See, yeah, different phases of the same sun. You can also observe the sun with some UV beads. Ms. Rita, I understand you sent them out to the libraries. Can you describe what they are?
You want me to describe them? Okay, that's the
Yeah,
hard one.
please.
So what I know about the UV light sensitive plastic beads is that they are light sensitive. If you make a bracelet with them inside with no sunlight, they will all look the same color. But when you go outside and expose the little beads, they will turn some of those colors. Of course, they won't be
Yeah.
perfectly in order like this young lady says, unless you actually show that, put them under sunlight and redo your bracelet. But Carolyn, you have to tell us a little bit about why the sun's rays change the color.
Yeah, these are specially chemically coated beads that will react to the UV light. UV light is not visible, unlike what we see like in a rainbow, right? So how do we detect sunlight? The beads can be our detective. And my question to the audience is, do you think the beads will change color on a rainy day or a cloudy day? Or will it only change color on a sunny day? What about putting them underwater or under a piece of white cloth? You can do different experiments with them and see the intensity or changes, right? Whether it changes at all or maybe a darker color or no color. So there are all kinds of fun things to do with the beads. All right.
I
I'm
did send
almost done.
everyone an
Uh-huh.
extra investigation sheet. So
Uh-huh.
not only do you can make the bracelets, but you can also do the other activity. And if you can't find them, just shoot me an email and I'll send them to you again.
Yeah, sounds like fun. So as mentioned, scientists will be studying the sun during the eclipse and also its impact on our atmosphere. So we know the Earth's atmosphere is mostly made of oxygen and nitrogen, but then further up, higher up at the top of the atmosphere, that's when the atoms are ionized. They are more like plasma. They are negative and positively charged. These are electrically charged. And every night during day and night time, there is a change of these electrically charged particles. But imagine during the eclipse, when the moon moves in front of the sun, it's from day to night in very short time period. So scientists are studying that and see how they may affect our signal, because communication signals are affected when there is a sudden change, when the atmosphere is all shaken up. And these can hamper our communication, especially of airlines, with GPS, our phone. So next time, if your phone is not working, you may wonder why. Check out the space weather report, whether a solar storm has actually caused some interference. All right, since you are at libraries, you are patrons of libraries, I wonder if you have any favorite books to read about the sun and especially about the eclipses. Here are some sample books. I only saw Jeff Bennett's book last week. I'm not endorsing any of those. Just to draw your attention to some of them and check out your local libraries. And here are some eclipse resources. We talk about the map. It's a NASA unique map that you can download from the website science.nasa.gov/eclipses. There are some fact sheets, facts on the back of a poster, and 2 more posters that you can download and print for yourself. The fact sheets and the safety flyer, as well as the box pinhole projector video, are almost done, translated into multiple languages in Arabic, Chinese, traditional and simplified Chinese, Tagalog, Vietnamese, and Korean. So hopefully you will find them useful, right? Especially for your household, if you speak multiple languages or 2 languages. Okay. So you may have heard about lunar eclipses as well. Besides solar eclipses, lunar eclipses happen a lot more often, and they occur at night when the Earth is between the sun and the moon. And when they line up just right, the Earth's shadow is cast on the moon. And lunar eclipses happen during the nighttime, very long hours. Find out all about eclipses and where to view them and more eclipse science on the NASA website. So science.nasa.gov/eclipses, or you can scan the QR code on your screen. You can also visit the HEAT website. That's from our team. It's science.nasa.gov/learn/heat. It has more than eclipses. It has a lot of other fun things, including the UV bead experiment. After April 8th, we hope you are interested in knowing a little more about the sun, and we invite you to continue following us with the Heliophysics Big Year. It's a global celebration of solar science and the sun's influence on Earth and the entire solar system. The Big Year is actually a concept that originated with citizen science in the bird watching community. So during their Big Year, birders try to observe and study as many bird species as possible. And so we challenge you to do the same with our sun. The Helio Big Year started with last year's annular eclipse in October, and it will end with the Parker Solar Probe's closest approach to the sun in December 2024. So I was very blessed to see the launch in August 2018, and Parker Solar Probe is the fastest flying human-made object. And it's going so close to the sun, we dubbed it as if touch the sun. When it approaches the sun in December later this year, it will be at the 4-yard line. Imagine a football field with sun on one side and Earth on the other. It will be at the 4-yard line going for the goal. So the Helio Big Year includes the solar eclipses and also opportunities for everyone to observe the sun, collect data leading up to a solar maximum. Remember the Fury sun with a lot of activities on it. We are approaching that 11-year cycle to the maximum at the end of 2024 and sometime 2025. So you'll hear a lot in the news about sunspots, solar flares, and CME, which is a fancy word for eruption, a big piece torn out of the sun, and also northern lights, auroral displays that may come as far south as New York City. Last but not the least, you can also connect with us by following the social media, X, Facebook, and Instagram. I think that's all I have. Thank you, Ms. Kyle. Back to you.
Thank you so much, Carolyn. I already have questions. Just because I've seen Star Trek 4 when they zip around the sun and like they get going really fast. So I'm going to, I'm going to start. And while I'm opening up everyone's cameras, that was my first question. Will the Parker Solar Probe actually go around the sun? Is it going that fast?
Yes, yes, it's going also around the pole. It has some gravitational assist from Venus. And it's going closer and closer to the sun and looping around.
Jumping around. If you would like to put a question into the chat, I like Woodside's little fireplace. That's great. There's a question there. Carolyn from one of our Hunters Point Library, one of our people there has asked if you have ever been to space.
I would love to. I was inspired by the Apollo, right, as a young kid. But early on, I decided that I am adventurous, but not that adventurous. So I'm very happy to work with NASA people and also curating NASA data and helping everybody to learn a little more about space. But I think the young audience should aim to go to the moon or even to Mars and beyond.
Here's another question from the same group. What was your favorite launch? Because I bet you've seen a few.
I saw the Parker and Solar Orbiter. Parker was launched in the middle of the night at 3:30 a.m. It is special because NASA never named a spacecraft after a living person. That was the very first time. Dr. Eugene Parker was 90-something years old. He was still standing tall. He was pint-sized with his family. He was very proud to be there to see a spacecraft launch successfully into space to study the wind coming off the sun and the atmosphere, the corona.
That's great. Okay, yeah. I saw a night launch of the shuttle. That was really incredible back in the day. Okay, so Woodside asks, hello, I saw a video that said this will be the last solar eclipse in our lifetime.
I hope not. As I say, eclipses happen quite often, but sometimes in very inaccessible area like the Antarctica or over the ocean. That happened in 2016. It was over Micronesia. And my colleague and Ms. Rita actually knows one of them, Troy Klein and Eric Christian. They have to connect flights and travel by boats. Took 4 days to reach their destination. So imagine one happening in United States, right? After 2024, it will be 2044, 20 years later, when it happens over United States again, but only over Minnesota, the northern parts of the country. Yeah, like a U shape and part of Canada. 2045 is the next time when a lot of Americans will see the next solar eclipse over United States. So you can add the math. Don't know how old you are, but add 21 years or 22 years.
Well, so it will be in some of our lifetimes.
Yes.
So how old will you be in 2025? We have a bunch of questions here. I'm gonna jump to one of our guests here at the Central Library where I am, just arrived, and she would like to know why you need special glasses to watch the eclipse, since the sun will be covered by the moon. And we did cover this, so there's kind of a two-part answer, Carolyn, right?
Yes, yes. So everybody will see the partial eclipse when the moon does not completely cover the sun. There is a lot of sunlight coming out. Your regular glasses do not block enough sunlight. The solar viewing glasses, the one that Ms. Kyle has in hand, is like 1,000 times more darker than your regular glasses. So you need the special filters, okay? Not just for your eyes, but if you have a telescope, a regular one for nighttime stargazing, you need a filter in front of your telescope. Don't try using your phone to take a picture of the partial eclipse because it will burn your lens and through the lens burn your eyes too. So you need the filter in front of your camera.
Why not? I think.
Thanks for the demo.
I know, I'm trying to keep up with you. Okay, thank you so much. One person in East Elmhurst would like to know why NASA studies eclipses. I know you gave a brief answer, but why
Yeah.
what do we see
Yeah.
during the
Great
eclipse?
question.
we
Great
learn from?
question. So first of all, I lived in Amherst. I forgot to say that. I lived in Sunnyside for a year and a half, and then I moved to Amherst and took the subway to Manhattan for college. So thank you, Amherst, for asking the question. NASA actually funded several teams to study the eclipse. We know we have telescopes looking at the sun 24/7, like the Solar Dynamics Observatory that I showed briefly with different coloring of the images of the sun. And there is one called SOHO that has been faithfully flying since 1995. We created an artificial eclipse out of SOHO, but the technology is not there. We cover too much of the sun. Now you see actions coming out of the sun, but closer to the very beginning of the atmosphere of the sun, we cover it. So whatever eruptions come out, whether they are flares or the CME, we miss the first few moments. The natural solar eclipses are the only time when you can see the corona with naked eyes or your camera. So for 2017, one team in our own building from here, Greenbelt, Maryland, traveled to Oregon, and they took 6,000 images very quickly, just within 2-3 minutes of that eclipse. And they tried to capture how the sun looks like. It's very, very close to the beginning of that atmosphere, close to the surface of the sun. That's only one of the many, many aspects. Yes.
Great, thank you. From Glen Oaks, do animals see solar eclipses differently than us since they see in blue and yellow? And I'm not quite sure
Yeah.
which animal sees in blue and yellow, but
Yeah, I don't know either, but great question. There are apps, phone apps that you can download. One is called Eclipse Soundscape. It is actually helping you to observe not only looking up at the solar eclipse, but also looking around you and looking down, listening and observing to birds, to crickets, to all kinds of creatures, maybe even flowers and plants and how they react to the sudden dimming of light, right? So different animals have different sensitivity to frequencies, whether they are the light sensitivity or sound or winds or temperature. There are all kinds of changes around you during the eclipse. Great question.
thank you. So if you were in the path of totality, it would get dark for a few minutes. But here in New York City, we're about we're 89%. So even though it will just be a ring, a small crescent of a sun, it won't get quite as dark because even 10% of the sun is a lot, right?
But temperature changes, you will still notice. Where the air temperature or the ground temperature, also there may be cloud pattern changes. So pay attention to this.
That's
And the
great.
Globe Observer is another app that you can download. It's a citizen science project. And they will start with the eclipse and they will continue with campaigns for a month or so.
I'm throwing things into the chat. All right, let's go see some other questions. We want one of the kids at the Ridgewood Library wants to know if the moon has to be in a specific position for the eclipse. And I know, Carolyn, you had that little video, so
Yes.
maybe can you share your slides with me and I can
Yes.
then I'll
Yes.
send them out so you can see the
Yeah.
video. But where does the
Yep.
moon have to be? to have a
Yes.
complete
So
eclipse.
the moon has to be lined up with Earth and Sun exactly, right? On the same plane. Just imagine your table is not tilted, is flat, right? That surface. Sun, Earth, Moon must be on the same plane. But then the moon is at a different orbit most of the time. It's like pitching your baseball. Sometimes it's too high,
Mm,
okay, and sometimes too low. But occasionally it's correct, is right, and that's when you score.
That's great. Look, I even just noted. 40, 45. Okay. So what else do we have? Let's see. What I knew this question was going to come when you mentioned it. What is plasma?
Ooh, it's not the blood.
Not your blood plasma. Yes.
Right, right. So you know, matter is made like your chair is made of wood, is solid, okay? And earth has both soil, rocks, as well as water. So those are solid, liquid. And then the atmosphere is gas, right? Or you can see it, or you use gas stove at home for cooking or heating. Now, there's a fourth state of matter. When gas is so hot, it is not stable and it will actually break into positive and negative ions. They are ionized. That's the plasma. So the sun is made of gas, like other stars. They are all made of gas and it's mostly hydrogen. But hydrogen will also turn into helium, and then they will also turn into other gases. And so the plasma actually carries ions, different components of oxygen and hydrogen and other elements.
Great. That's a really complicated question. Is the eclipse cycle, also from Elmhurst, always 11 years long?
Oh, I love that.
Longer? Shorter?
Eclipse cycle, there's eclipse season. I think it's 30 some months. I don't know, but it is all on our eclipse website. There is one question, I think, in the FAQ about eclipse season. Yeah.
Okay. So
But it's not, it has nothing to do with the Earth, the sun's magnetic field, which dictates a 11-year cycle.
the sun is very different from the earth. It's much, much bigger, right? That was what Carolyn started with, is
Yeah.
how many earths could fit inside the sun. How many was it? A lot.
More than 1 million.
A million earths. So the sun is really big.
Yes.
So it does have, I can expect it would have its own weather and its own seasons, which is kind of cool. Let's see, one of our guests at Central would like to know more about the solar maximum that we're, I guess, in right now. It's like the peak of the 11-year cycle.
Yes.
And what kind of solar activity will there be?
Good question. So when the sun is quiet, I don't know if you remember one slide when I show it side by side, a quiet sun and an active sun. During solar minimum, when the sun is quiet, there may not be a single sunspot. So sunspots are dark regions because the photons, the lights cannot escape out of the active region. The active region has magnetic field hovering over it. You can't see it, but it's there, right? And so it appears darker to telescopic views. In 2006, when I went to the eclipse in Turkey, for 3 months leading up to that eclipse, there was 0 sunspot. The sun was totally calm and unexciting. That's all I can say, right? But on the day of the eclipse, actually there were 3 sunspots. So when we were showing the telescope, we were streaming and said, oh, there are dots on the sun besides the moon moving over it. So during solar maximum, there are many, many more sunspots. And with the sunspots, sometimes the sunspots will grow, and then they will snap and burst open, much like chewing gum. sending storms into space. And so I was reading the weekly report. There are at least 3 storms per day now, and the activities are picking up. And there are many, many sunspots of big and small sizes. And each sunspot actually is bigger than the size of Earth.
Wow. One of the things that I do know is that when the space weather, when there's more activity on the sun, there are more auroras here on Earth.
Yes. Yeah.
So those of you who've ever been up north in Canada or even Vermont, so one time I saw the aurora. So that's
Right.
been, yeah, solar, wind is
Uh-huh.
somehow affected by the Earth's magnetic poles.
Right. Right. So the big eruptions coming from the sun will take several days to reach us, and there are all kinds of forecasters watching, and a satellite like a goalie very close to Earth, keeping watch of the solar wind's arrival, and they can predict whether the solar wind is shaking up the Earth's magnetic field and causing the excitement in the atmosphere. So now when oxygen and nitrogen are excited, they will give off different kinds of lights, different colors. And in 2003, there was a very famous storm called the Halloween storm that occurred in late October, early November. And I was in the Catskill Mountain area. Actually, our colleagues saw the aurora in upstate New York.
Beautiful.
So when the storm is active, it may push the northern lights further south, maybe into New York City.
Wow. That would be great to see the aurora at night, even if you're way out in Queens, not so much light pollution. I just put a picture from the Solar Dynamics Observatory in the chat. If you go to the link, it goes through the different images that we take of the sun every day. We've got a question from Glen Oaks.
Yes.
How do you know what type of eclipse is going to occur?
Because it has everything to do with the orbital mechanics. We can calculate the time, right? The period that it will happen. So in fact, we had one scientist who has retired from Goddard. His nickname is Mr. Eclipse because he made a calculation, a book of calculation for 5,000 years of both the solar and the lunar eclipses.
Do I know that person?
Yeah, Fred Espenak is his name. He's
That's
still
amazing.
active. Yeah, but he has long retired from Goddard.
Yeah, that's great. And I think even people in ancient times
Yes.
were they able to calculate solar eclipses?
Yeah. Oh, thanks for asking that, because we have a Minute Earth video that actually talk about Babylonians and Chinese and Egyptians and all that, and how it happened in a season of 18.5 years.
Okay.
I
So
will
that's
give you the link. Yes.
great. So we'll get a link for
Minute Earth. Yes.
all right. Sounds great. Are there any other questions? Let's see. I'm looking, Grace. Have I missed any? I did put a note in the chat. The Queensborough Community College is working with the local New York Goddard Space Flight Center office to do a big solar eclipse event on the day. And I think that's up by Bayside. But I wanted to make sure crew heard about that. Are there any other questions? I see children talking, so they're probably have some more questions. You have some more questions, ladies at Glen Oaks? You can just ask your librarian to type it into the chat. It looks like, I think we've gotten all the questions. Thank you all so much. You guys can type in a new question? Yep, there we go. Grace, please put some questions in the chat. Because we are closing. We'll be done in about 5 minutes. Oh, there. Thank you, ladies. When I can't tell exactly who you are, so youth. When does the solar eclipse start and for how long does it last? And I know that's a multi-layered question. Thank you for that, Glen Oaks.
Yeah. Yes. So you can look it up from the NASA map or use some third party. I'm not supposed to endorse anyone, but we do collaborate with time and date. And also Cosmic Story that is based in Harvard, Harvard in Boston. And you can put in your city name or latitude and longitude, and you'll find out exactly when the eclipse will start and end. So in New York City, I look it up, it's about 3:16, right? In the afternoon, and yeah.
Yes. And I'm trying to look at it right now. And so it's only, so what's exciting about this eclipse is, to me, it's a few minutes of 89%. But like you said, it's 90 minutes across time. So if you start watching in the beginning, you'll see a little chunk of the sun and then more and more and more coverage until it's almost all covered. And then you'll see it you'll actually be able to sort of sense the passing of the moon across the sun, which is really exciting. And you can also, all of the libraries will be given the NASA YouTube and live stream links. So you could start your day by looking online and check, because NASA will have spotters, right? All across that path. And so in the last eclipse, I had it on all day. And I just watched every group experiencing, it was going from Washington State down to Texas, and it was so exciting. So, you know, it might be cloudy here. That's what happened last time, but it might be sunny. So we want to be ready.
Yeah, thank you for bringing that up, because the broadcast team will have a 3-hour programming. So there will be interviews for observers along the path. There will be also pre-taped segments. There will be a live telescopic feed. So every station, every location along the path will have a telescope set up to capture the moments. There is also a Spanish programming channel between the Exploratorium and NASA headquarters.
Oh, yes, I saw Exploratorium was
Yeah, they will be in Junction, Texas. I personally will be in the Dallas Arboretum, and we have a broadcast team with us as well.
That's so exciting.
Yeah. Good Morning America will be also co-located.
It's very exciting. I know the president of the library, the chief librarian, is going up to Rochester. He'll get to see it. His son is very interested in the eclipse. Glen Oaks, I know you have one more question. In the last few minutes, can you explain, Carolyn, the diamond ring effect and when you see that?
Okay. So you have to travel to the path of totality, to that 100 miles wide path to see that. And I was lucky enough to see 3 times. So when the moon slowly moves in front of the sun and eventually blocks it all, there are still last pieces of sunlight peeking through the valleys of the moon. Okay, the moon is not flat. The moon also has valleys and peaks. So sunlight is trying to escape from the valleys of the moon. And so they formed a string of beads, and we call them the Bailey's beads. And then the very, very last piece that comes out of it suddenly is all consolidated into like a piece, like a pearl, okay, or a diamond. And that, you know, the totality has begun. That's when you can safely remove your glasses and look up and see the atmosphere of the sun, the corona.
That's great. I'm afraid, except for when I was very small, I've only seen partial solar eclipses, although I have seen them in a variety of locations. So I'm pretty excited. I hope you are all excited. I hope you're all going to be very careful with your eyes and wear your solar eclipse glasses. There's a safety flyer from NASA that goes along with every pair of glasses. So I will call your attention to that. Make sure that if you're taking glasses home, you, your parents, have that safety information. And we're excited to celebrate the solar eclipse with you, and we're very, very grateful. Yes, Glen Oaks, we will share all the links from the chat. We're grateful for Carolyn's time today. I want to say thank you, and I hope everyone can put their thank yous in the chat. It was really nice to spend time with you today, Carolyn,
Thank you.
and we're so grateful. Thanks to everyone. Thanks, Grace. Thanks to everyone who asked questions. And we look forward to sharing. If you can send me your slides, I'd be happy to share that because it's got some little movies in there that are great. And thank you from Hunters Point. Thank you from Glen Oaks. Nice to see you. I think that's Alex there. Thanks for coming. And I hope everyone has a great day. And if you have any questions about the solar eclipse, you know where to find me. So thanks, everyone. Have a great day.
Thank you.
Bye, Carolyn.
Bye-bye.
Bye.